Good morning everyone present here. My name is Zit Ladani. I am a student of Indian Institute of Information Technology, Vadodara International Campus View. So we have our project Geothermal Energy Power Plant in semester 2 from the subject Electronics Engineering. I have prepared this project under the guidance of Dr. Jignesh Patel. So let's discuss what is geothermal energy. So basically, what is power plant? A power plant is a plant-based thing which uses natural resources to produce electricity. So let us discuss how it produces electricity in geothermal case. Geothermal power plants are a key component of renewable energy landscape. As we know that our Mother Earth always produces heat continuously in the Earth's surfaces. So our plant uses that steam or the heat to produce or run the turbine and which produces electricity. The key concept behind geothermal power plant is simple yet powerful. The earth continuously produces heat due to the decay of radioactive materials and residual heat from its formation. By accessing this heat through wells and transferring to the surface, geothermal power plant can generate electricity efficiently and with a low carbon footprint. So our geothermal power plant is way more beneficial than other power plants. What are different types of geothermal energy power plants? There are basically four or more than four types of geothermal power plant. Dry steam power plant. This uses simply the steam from the earth's surface and run the turbine which produces the electricity. Binary cycle power plant. Binary cycle power plants uses some low boiling points fluids less than water such as isobutane and isobentane. These fluids are then exchanged with the secondary fluid in a heat exchanger and this reaction causes steam and this steam is used to run the turbine and which generates electricity. So flash steam power plant. The steam generated in the flash steam power plant is coming from the high pressure hot water from the underground reservoir, and this reservoir generates steam, and this steam is then used to run the turbines and which produce or generates electricity. Hybrid geothermal power plant. Hybrid geothermal power plant suggests that it is hybrided with some other things. So here we can use solar power to generate or heat which heats the fluids and that fluids produces steam. So this is basically used to boost the turbine speed and which also increases the voltage coming through the generated electricity. So going to the applications of geothermal power plants, there are several applications. The first basic application we have is electricity generation. Geothermal power plants primarily generates electricity by converting geothermal energy into electrical power. Geothermal energy over here stands for steam. The heat from the underground source is used to produce steam. As we know that our Mother Earth produces steam due to the several radioactive elements and this steam drives turbines to generate electricity. This application is particularly valuable for providing base load power as a geothermal energy is reliable and continuous source. So it is also beneficial because it is continuous source, never ending source. Geothermal power plant can also use in mineral extraction. When the minerals are extracted, it is dig down into the earth surface which produces steam. So that's why it can also be placed where there are minerals extraction. Geothermal energy can be used in thermal energy storage systems where heat is stored and released as needed to meet energy demands. Geothermal heat can warm water for fish farming, providing stable and controlled temperature for various aquatic species. Geothermal heat is used in industrial applications such as drying crops, heating industrial processes, and desalination. So let's come us to the favorite topic, working. So there are several steps which needs to be considered while doing some geothermal power plant. Which are they? Geological surveys. As we all know, we cannot place geothermal power plant as we want. We can place it where there is a high chances of getting steam or it is surveyed before planting that plant. So there are several steps which needs to be considered. That is earth surface composition and geothermal characteristics to local let or suitable sites for a power plant. Now, the second step which comes into the consideration is production well drilling. Once a suitable site is identified, production wells are drilled to access the geothermal reservoirs. Means a driller comes to the act and it drills the earth's surface, producing the steam through the hole the well or it is drilled, and that allows the hot water or the steam to flow to the surfaces. The third step comes into the consideration is steam separation. As we know that steam only can run the turbines, not the hot water. So there is a steam separation in a separate way to separate the steam and the water, hot water from the extracted from the earth surfaces. Then the fourth step, turbines and generator. The steam or vaporized working fluid drives turbine which are connected to the generators. As the turbine spins, they generate electricity. As we know that something which turbines or means which rotates with a high speed have the potential to gain some electric energies. Fifth step, cooling system. After passing through the turbine, the steam or vaporized working fluid is cooled and condensed. Cooling can be achieved through cooling towers, ponds, or other systems. As we knew that steam always evaporates and forms the water. This water needs to be cooled and then also transmitted to the safe place. So we need to also cool the hot water and the steam water which it has been come from the steam, and this can be transmitted to the slab basis. Transmission and distribution. The generated electricity is transmitted to the power grid for distribution to consumers. This involves high voltage transmission lines and electrical substations. As we know that the turbine has generated the electricity, now it's time to deliver it to the consumers. This can be achieved through various steps like providing it to the main transmission lines and electrical substations. Monitoring system. Geothermal power plant use monitoring system to track pressure, temperature and other critical parameters. This helps to ensure the plant's efficiency and safety. As we knew that if we run any plant, we need to take the safety measures and efficiency wise it should be more beneficial. So these all are the 7 steps which needs to be considered while planting a geothermal power plant. So let's understand through this photo. So as we knew that this turbine digs the hole inside the earth's surfaces and this have the hot water. So when it's coming through the turbine, not turbine but basically this earth surfaces, it brings steam and along with hot water. Hot water and steam are separated through this separation field, and only steam is passed through this and the hot water is passed to the cooling tower. This turbine runs as the steam is flown through it, and when the turbine is flowing rotating it generates the electricity, and the generated electricity here is transmitted to the substation tower and the other various consumers, and the hot water remaining over here is also passed to the cooling tower. This cooling tower cools the water and inject it to the well and also to several cases or several other aspects. So moving to the other benefits and pros of our geothermal power plant. Low operating costs. As we knew that the natural resources of steam production is continuous and infinite, so it has low operating costs. Once the constructed geothermal power plant has relatively low operating and maintenance expensive due to absence of fuel requirement. As we know, there is no fuel requirement like coal, kerosene, or petrol. So there are low operating costs for the geothermal power plant, which is a strong point of this power plant. Reliable base load power. Geothermal plants are not dependent on weather conditions like wind or solar power. They can deliver consistent power around the clock, making them ideal for baseload electricity generation. As we know that it does not depend on the sun energy or any wind energy. So it is also reliable baseload power. It can always generate baseload power as the requirement are there. Environmental friendly. Unlike fossil fuel plants, geothermal facilities produce minimal emission during power generation, making them much cleaner alternative. So as we knew that it does not produces any type of carbon emission things to the atmosphere. So it is very much environmental friendly and renewable and sustainable. The Earth's internal heat is constantly replenished, making geothermal a renewable energy source. With proper management, these plants can provide a long-term sustainable solution. So these are the four basic points which make our geothermal power plant sustainable, renewable, with low operating costs and beneficial than any other power plants present in this country. So, is there any improvements in geothermal power plant? Yes, there are. First, improved drilling techniques. Current drilling technologies can be expensive and limited in depth. Advancement in drilling efficiency and cost effectiveness will make geothermal power plant more accessible in various locations. So, one needs to dig or the drill the things much deep inside the Earth's surfaces, which creates more energy or more natural resources as compared to the current scenarios. Advanced materials. Developing new materials for geothermal plants that can withstand high temperatures, corrosion, and harsh chemical environments could improve efficiency, durability, and reduce maintenance cost. So we can also make the materials in the power plants more efficient, which can produce more energy and withstand some corrosion, some high temperature waters, and improve the efficiency, durability, and reduce maintenance cost. Wastewater management. Geothermal plant plants use water or brine to extract heat from the Earth's surface and usage and developing efficiently reinjection or treatments for several responsible environment. Wastewater management. As we knew that steam which gets evaporated to the water and the hot water coming from the Earth's surfaces needs to be cooled down and then we can use that water or manage it to through various fields like putting it into agriculture or maybe some industrial purposes. So these are the basic three improvement scope in this current power plant. But still, it is going good and far enough better than any other power plants. Conclusion. Geothermal power plants offer a compelling solution for clean and reliable electricity generation. Their advantages include minimal environment emission, which we have discussed earlier, sustainability due to the Earth's constantly replenished state, which is our key point of our thermal power plant, and the ability to provide base load power regardless of weather condition. That is also been discussed in the last previous slides. So these are the three basic points which make this our geothermal power plant apart from any other power plant. Additionally, they have a small land footprint and require relatively low operating cost after construction. So only the construction is the cost required, and then after that only low operating costs are required, like some machinery things or few more. They have a small land footprint, means that does not require acres and acres of land and require low operating cost. However, it's important to acknowledge limitation. Geothermal power plants can only be built in specific location and with access to geothermal resources. With advancements in technology or promising to expand usable resource, upfront cost can be high. So there is only disadvantage in a power plant, that is it should be location specific. That means it cannot be created like we want. It should be created where there are the places it can be or with the steam it can produces. Thank you. I think that I have been discussed the topics far enough and explainable way, and I hope that the topics are explained thoroughly through your mind. Thank you. Thank you, sir.